Formatting output. There's different ways of doing it. The one way that Hudson has his notes is through string. If you want to see additional information, here's some Java sources. Now, you have been taught formatting, or should have been in 231, but the instructor might have did it differently. I glanced at Christian Jacobs. He actually talked about F string, and I'm not sure he talked about the way that Professor Zhao had mentioned. It's using the format specifier, like a %S, %F. And I don't think Neil Wang actually talked about it. I did, but my people could have forgotten. So consequently, I have a review that you can look at. I'm not going to take the time to show. This is a format specifier. But I will show the equivalent of this. I'm skipping through all this, the Python part of it. This is just should be a review for you. Oops, review for you. But besides having this, there's also a considerate link over here to the shortcut link to the weekend lecture where I talk about it. If you need to look at some lecture notes, the complete ones, as well as runnable Python examples. Now, this format, the output, you're using, and I talked about format specifiers, not just because Zhao did, but because even though that's an old approach to use in Python, a lot of other languages use format specifiers. C does it. Also, Java can do it. So you learn the same approach in multiple languages. So I show part of this program here. You can set the number of places of precision. That's actually the easy part, so I don't have screens for that, I believe. But I'll show the running of the program. Setting the field width and the precision. The field width is this. When you have a piece of information, it's going to take up a certain amount of places. The string high takes up 2 places. Well, don't do something stupid and say the amount of place I give it is smaller. Most languages will expand it, but it could cut it off. And you don't typically want to do that. You could set it wider if it's wider than the field width. So if the whole width is this, that's the space you allocate, and then the data is this wide. Well, there's 2 possibilities now. It's either going to have leading spaces, and from my perspective, this is right aligned, or it's going to have trailing spaces. From my perspective, left aligned. Trailing spaces, left aligned. Leading spaces, right aligned. And this, if you've used a spreadsheet, when you have the columns, each variable is like a column, and you can left or right align these. But before I talk about how to do the left or right alignment, the idea of format specifiers is you have a placeholder. The placeholder, you pass to string format a string between the quotes here, but you can format it. I'm not going to do a formatting because I'm trying to keep it simple. This %S doesn't literally appear. It's like that \n. It's saying it's a placeholder for some information. S is for string. We'll talk about what the types are. F is for float. If I have a placeholder, we have to substitute something in. A string is a variable, stores high. So high will be substituted at this point. Then there's an underscore, and then it's followed by a placeholder for a float, which is the value of the real number. So this value subs in here. Now this number is this, but by default, it picks the precision, whatever the designer's in. And we get as output now, temp is stored in this. We could have this nested in here, but I'm trying to keep it simple. Now we can pass temp here, and it displays high, the underscore, because that's what temp string has, and then it's followed by this. So this is just demonstrating no formatting, but just the idea we don't literally have what's between the quotes if we have the % sign. The different types, some of the different types of placeholders for the format specifiers, and you can see the full reference, the Geeks for Geeks here. So how do we do? The toughest part is setting the field width. The general, if we want to do the formatting, it's a field width. And then we can have, we have placeholders. Example, we just have a single placeholder here and then data. A string is high and we give it 5. Now, and then it's going to be followed by an underscore. Well, high is only 2 characters. So it's either going to be followed or it's either going to be followed or preceded by spaces. If the number is positive, then it's preceded by spaces. That's the rule of thumb. You can see this. If it's greater than this width and it's positive, it's preceded. 5 is the width, 2 characters, leading because 5 is positive. On the other hand, if it's negative, so I have the same number, then it's going to be trailing spaces. And we have 3 spaces. And I have output here, so you can count 1, 2, 3, 1, 2, 3. That's how we set the field width. Now, setting the precision, I don't have, no, I don't have the screen grabs here. I didn't think I did. Formatting. Let's see example. Click on this example. I remember which one it was. Fixed input, getting input. Automatic input, can't remember off the top of my head. String example. I saw it here a moment ago. Where the heck was it? Was it part? Oh, it's part 3. I'm a fool, that's why. I overwrote it. I saw it a minute ago, but I overwrote part 2. Oh, yeah. Part 3. I was looking for formatting. I knew it's called formatting. So we have the ones with positive, negative, and now we can set precision. It's a dot, and then the number place precision. 1 place, 4 places. Slow. Oh, week 2. Give it a little better name. Just to make it more unique, easier. So this is the leading spaces. Formatting precision, 1 place of precision. And then it looks like it's 5 places of precision. Setting the field width and precision, the syntax, 1 place of precision, obviously. This combines it. And or is it IntelliJ here? So 1 place, 4 places. And don't do something stupid and try and do it with a non-floating point values. You get unpredictable. Unless it's an integer, you're going to get unpredictable or syntax error, logic errors. So now we can set the field width and the precision right here. This is in front of the decimal left. This is after decimal. That's the basic part of it. This part, types of errors, I only include because Professor Hudson includes it. It's a review, but you really should know these terms. I put it here just so it's available for reference. Although the content of 231 and 217 are similar enough up to this point that 219 lectures and 233 lectures basically can overlap. I've gone through the material just to see if it was appropriate from previous semester. And if I didn't think that there's a way of improving upon it, I just use the same video. However, here's a case where I've added some additional things because in 217, I can see that you probably don't have as strong a background as they had 231. So this will be, it shouldn't be new, but it'll be a reinforcement of the differences between primitives and other types, such as objects. So we have primitives. I describe them as atomic types. They can't be decomposed into other types. And even though Python has that screwiness where even these ones are references to objects, it doesn't matter. An integer can't be decomposed into parts, and that's one reason why I use that term atomic type. It's a single memory location in Java. Now, when I was teaching 217 and 231, throughout most of the course, I said, think of it as a single memory location. In Java, it is just a single memory location. So it's like a single mailbox in memory. Or if you prefer an Excel spreadsheet, a mailbox can hold one piece of information and no more. Or if you think in terms of an Excel spreadsheet cell, if you type something in a cell, what was there previously is gone. It can store data essentially. That's another key part. Numeric information, whether integers or floats. A single character, and that's different from Python, where a character type is not a string with a single character or a Boolean type. So this gives you a memory location that's labeled as age, and we put 0 there. Straightforward. This then goes to that same location, overwrites it, and now puts 37 in there. That's fairly straightforward. And in my opinion, that's the way Python really should have implemented things rather than complicate it with references. But nonetheless, with Java, this is a single memory location, not all the crud that you get in Python with references and then the actual integer itself. Now with objects or lists in Python, you actually had two memory locations. I say arrays list slash list because essentially the rough equivalent of a Python list in most other languages is an array. As you'll see in later lectures, an array doesn't do all that a list does, but it's a composite where you can access the entire list or array, or you can access individual elements, and the reference is involved. So you have two memory locations in these cases. A reference, which contains an address of either the object or the array slash list. And I'll illustrate this. Think of it this way. The list or an array is a composite. That's where that name really stands out. It consists of individual elements. It's like an apartment. You have two memory locations here. So the actual list or array, that's like the building. And it's composite because we can access individual elements. There is the suite number of individual locations. However, the building itself has an address, and that is like a reference. So that address, that reference, is like a piece of paper. That's a metaphor I used when I was teaching 231 and 217, which is obviously, I use this metaphor because it's obviously that piece of paper is separate from the building. I'd sell you a piece of paper. It's obviously not as good as giving you the building. Or in other ways, instead of the piece of paper, it's what you have stored on your phone electronically, which still is in the building. Two separate things. Or in short-term memory or long-term memory, your address of the building. That's the metaphor to use. When we create a list in Python, we have the two things. We have one, a memory location called a list. That memory location doesn't store data, but it stores an address. And distinguish the data from the addresses, I use that at. It's pointing at a location. That's my own notation, but it helps you distinguish between me just putting a number here and me putting a number here. This is indicating an address. It points to or refers to another location in memory. Memory, or RAM essentially, is essentially like mailboxes, super mailboxes, where they're labeled, or mailboxes in an apartment. They're labeled with numbers as well as names. So in this case, I arbitrarily picked off the top of my head address 100. A programmer typically doesn't assign addresses. The operating system does that. So this one refers to that location here. And in the second location is where we have the actual list. So I'm using a Python example here because we actually haven't talked about arrays. So when I first reintroduce, hopefully it's just a review here, references versus the data, using the Python example will help you more easily see what's happening. However, taking more time for this, we have over here an illustration of the primitives versus the more complicated types, the composite with references in a Java program. We have, oops, and this is where Python really stands out on the side here, where you can just start writing your program without all the extra overhead. I have two simple types. num1, this is a separate memory location. Num2 is a separate memory location. And this, I use that metaphor of essentially photocopying, copying what's in num1, a snapshot, that's what a photocopy is, and put it in a separate location. So we have primitives, and we display num1 and num2. However, this illustrates, at this point, it'll still be 12 and 12. Two separate locations contain the same data. But this illustrates that they're two separate locations because I can change num1 without changing num2, and we'll see the difference between these two. And this press enter to continue. I needed all that crud with the scanner to be able just to pause the program because we have additional stuff. I don't want to overwhelm you with too much at once. If I run this, oh my goodness, and it's awfully slow, even for just a simple little program, and this is a gaming machine. Okay, so we have the primitives here. The first print ln here is when we just copied the snapshot, but this shows that they are two separate locations. We changed num1 without changing num2. Now this press enter continue, pausing it so that you can actually see what happens when we have a reference, in this case an address. Okay, arrays. Now we haven't gotten to the syntax of arrays in Python and Java, but in terms of the basic idea of it, it's an entity that consists of individual elements. See, the syntax is a little different. Here's how you actually create an array in Java. We specify the type, square brackets indicates it's an array, and then we specify the number of elements here. Again, we'll get into greater details later, but I needed something that, or actually wanted to have a Java example, so I wasn't just talking about Python lists. Now, I'm individually going through the elements, so this is much like Python, and we're just setting this array to various values, 1, 2, 3. And now this part, I have a message here indicating what we're copying. We're copying an address into array 1 and 2. So if you go back and look back at the notes here, what I'm going to do is copy essentially that piece of paper from one piece of paper to another. So I have two pieces of paper essentially containing the address of one building. And that's exactly what I do here. It's like photocopying from that one piece of paper from here to here, or file stored on my phone with the address. I copy it to another file, but both of them refer to that same memory location. If this is still a little bit on the screw side, and I'm taking more time than I would with 233, because I realize that this is one where you didn't go through stuff. Another way of looking at shortcuts, a technical way, is I have over here on Windows system, I have essentially my 219 folder. So a simple type is, what can I actually copy over here? Well, maybe I'll create something. Okay, this isn't really pretty. You have the option of working on the 219 versus the 233 project. And this isn't really pretty here. I'm just going through the previous ones and I'm arranging them so it's nicely by topic. Okay, so this is the answer of what Hudson said, the difference between you have the option of doing the 233 project if you wish to. The contents aren't hugely important. Now, if this was treated like a primitive, that would be the equivalent of me actually copying the file. So num1, num2. And this is computer literacy. You know, if I edit this, where the heck did it go here? 219 versus, okay, copy of. If I edit one, and oh my goodness. So I delete the stuff in the, oops, I delete the stuff in the copy. That only changes the copy. And of course, the original is still there. And this isn't privy because if someone starts asking, should I do 231 versus 219? I just copy pasted what Hudson said and I'll send you the answer. However, the idea of the references is like a shortcut. We see shortcuts over here. This isn't a copy of a folder, but it's a shortcut to a folder. So for instance, if I go to the copy and I make a shortcut, and I access that 219 versus 233 copy versus the shortcut here, I really should just close this. I'm actually working on the video, so I need this in a moment. So inside the shortcut, I had text. And I think they're two separate files, but here's a clue that I'm actually working on the actual file. And I open up not through the shortcut, but through copy, thinking that it's two separate ones. And see what I just typed in here. That's basic computer literacy. And you have the Mac equivalent of this. So what I'm doing right here is I'm copying, if one way of looking at it is copying the address from a piece of paper here to here. Another way is essentially I copy a location on the file system. That's what a shortcut is. And I have basically something else that points to the same location. Now, if I don't know what I'm doing, when I print the contents of array 1 versus array 2, we think that we have two separate arrays. Now, this is really awkward looking right here besides the println, but you haven't learned the syntax of loops yet, so I'm just manually going through element by element here. Okay, so we're going to see the contents, potentially thinking that they're two separate arrays. 1, 2, 3, 1, 2. But we're basically displaying the same thing. Now, when I actually try and modify, and I think that they're two separate arrays, but I modify through the reference right here. I say they point to the same array, modifications produce the same result. Array 1 and array 2 point to the same location, the same memory location, RAM, wherever the heck it is, of that one array. Two separate, actually I have three locations. One reference here, and the actual array. And both these point to the actual array. When I follow that reference to the actual array, and I change it to 888, when I think that I'm displaying the two separate quote arrays, that index 1 and the apparently two separate arrays will be the same because it's just one array. And prove it now. See, index 1, it's the same. So this is a actual Java example to illustrate the difference between the primitives, one memory location, versus when we have references. One example of reference in Java is an array. Another one you'll see is an object that it's two locations. And I recall going through the concept of a deep versus shallow copy in great detail. You should have had it in the other lecture as well, although you might not have gotten in great detail. That's an example where I fell behind the other lecture, because that's such an important concept. You see it reapplied here. But we'll get to the deep versus shallow copy, another review again, or just reinforcing it if you really know it later on when we talk about arrays. So again, don't fret that most of the original video lectures are essentially the same as 219 versus 233 because the content's the same. That's why if you've taken 217, 219, you've fulfilled the equivalent of 231, 233. But I'm also cognizant, you're fortunate in that I'm cognizant that I've recently taught 217. So all of you, or most of you, have taken 217 recently in the last fall. So I know what you've seen. So I add these additional things to help you out. In this case, here's some material that I would be adding this semester, whether I would be teaching 233 or 219, because the additions in Java. Using these new additions aren't mandatory in this class at all. As Hudson had described when he sent out an email about this is just one show you that these new tools exist in the latest version of Java, and that we're aware of them. As well as in one case, there's actually one might regard as using it could be bad style, as you'll see. IO, now this isn't bad style. It's a shortcut that's available in Java 2.5. To set the context, the approach for displaying output in Python is significantly more cumbersome. Well, it's slightly more cumbersome than the print in Python. You have all this additional baggage. We'll explain what it means, essentially difference. Although the plus is you get more control over the new line. This one doesn't have a new line, this adds a new line. It gets even worse when you get text input because compared to Java's input, it's just a call to a function. On the other hand, you have to do all this, import the scanner class, import the name of the scanner class, instantiate an instance of it, and this kind of looks rather on the strange side. What's this? And then finally, this is where it's slightly better than Python's 3.03's input function, because this only returns a string. Now we've got different methods, different approaches for getting different types, so we don't have to do a conversion. But there's a lot more overhead for this. So the I/O was a shortcut for this. The API, you want to see it, there's not that much to it. It's meant to be simple, so it's bare bones in terms of methods. IntelliJ isn't great in terms of explaining how to get up and running. It's not so much up and running with Java I/O, but it's 2.5. For instance, I fiddle around with it. The version of Java 2.5 that came with IntelliJ was screwed up. I had an empty program, had some issues. And then I have downloaded Java 2.5 manually, and then I could run it independent of IntelliJ. And then I tried to import it, and it worked. And using Java I/O worked after I upgraded to Java 2.5. It didn't work when I had Java 2.3, but then it said that the version that I actually tried to import that I downloaded, IntelliJ didn't like. Perhaps it was in a funny form. So it's not mandatory to use this. So I stress this again. And if you're using IntelliJ, this is one of the glitches, the annoyances of IntelliJ. It's very powerful, but the things I don't like about JetBrains software, it includes PyCharm, is it's fairly slow, it's fairly complicated, and especially with IntelliJ, there's glitches for very simple things. With just basic Java, I had to download 2.5 and bang, I was done. It worked. With this one, I went through many convolutions. And it was still giving some problems. Now back to this. Once you get it up and running, it's convenient access to getting input and output essentially. So how it works is there's no import necessary, period. To access out, it's through here. It's a little bit shorter, println. Now you can't do fancy formatting that you can with the system.out. Unless perhaps you create the string and add things like whatchamacallits, escape codes, although format specifiers aren't really possible. However, here's where it's nice for getting input. You don't have to have the import. You don't have to instantiate an instance of a class. This is the I/O class, just called readln. It's a lot like Java Python's print, because it just returns a string. If you look at the API, it doesn't have additional methods for getting other types. You're going to have to do conversions. So that's the in and out of, no pun intended, for class I/O. Second addition to Java 2.5 they'll talk about. Again, you don't actually have to use it. It's the VAR, and some regard it, or at least under some circumstances, that the use of VAR may actually be contrary to good style conventions in Java. Under certain circumstances, however, to present a full view, it actually might have some advantages. Now, bit of review here. Declaring variables in Python is actually bad, straight out, in my opinion. We have the type of the variable determined, well, in this case, have some good style where I'm indicating the type of information here, but really what determines the type that's stored here is what's on the result of the expression, whether it's a constant, a math expression, or something else. Could be a concatenation, it could be a return value of a function or method. It's bad style, in my opinion, because there's nothing to prevent us from actually putting, say, a Boolean or a string or something else, or a picture referring to an int. It doesn't actually enforce in a language the type that will be stored in that location. On the other hand, as you should know, although it looks like a pain, Java actually requires you to explicitly create that memory location before you can put anything there. And on top of it, it forces you to specify the type, and you can't, well, I won't say you can't, but under most circumstances, you can't put a different type here. You can try and force it. And under certain circumstances, it does work out, say, with numeric types, but generally you should mix and match, and that's a good thing. The VAR, when used to bypass this, or it actually obscures the type, is where stylistically it's bad. Now, with the VAR keyword, essentially, VAR is used in other languages, but in this case, it means that we're declaring a variable, but we're not specifying the type. So very much like the Python approach, the type of what is stored in an int is the result of this expression over here. There are limitations use of VAR. It only works for local variables. It doesn't work for other cases, such as declaring, we use the term class attributes. They're the pieces of information that you get associated with each instance of a class. Now, in this case, I'm using a Python example because we haven't talked about defining classes in Java at all. So we can't actually use the VAR here. Unlike in Python, where the type is determined by its expression, we actually have to specify a type here. We can't use it for parameters or method parameters in Java because there's no functions, nor can we use it for method return types. So that's a limitation. There are some advantages, so I'm trying to present you with a balanced view of this. Now, I don't necessarily agree with this particular example one I found here, but I looked for other people's view of advantages, might reduce clutter. Now, this is a Java for loop, which is basically implementing the same thing as a Python for loop. You haven't seen the syntax of it, but essentially it's counting from 1 to 10. And the nice thing about it is, and this is increasing I is equal to I plus 1. Nice thing about it is, as an aside, the for loops in other languages other than Python are very explicit. Set it to this value. Here's the stopping condition. It excludes 10, although you could also put other expressions. And the reducing clutter is normally we'd have to specify the type here. We don't. That's where I kind of debate whether people putting this example, it reduces clutter, but I put it for the sake of fairness, balance. However, this is one that I think is an advantage. If you do what's called refactoring code, that means when you're actually redesigning your program, in this case, the function or method return type, you actually have to specify a type. If you change the type within a reasonable amount, using that VAR will still work. So you don't actually, if I declare this as an integer, and we are calling this method return numeric, say I had one version of it where I actually returned a long. If I had this long type stored in an integer, it'd be a problem. Then I'd have to change all the calls to it. But because I didn't specify it, I said I'm returning numeric here. And maybe I could say return whole number would be even better. Whether I actually use this one, I think, wait, I don't need a 64-bit integer. And then actually use this one that's commented out. I want just a 32-bit integer. It'll still work. So in this case, the use of the VAR, I don't have to fix all the calls to that method. That's actually, I would agree, that's a good thing, that one case I think of here. Over here, something that, and I wouldn't necessarily disagree with this one, where the variable declaration, cleaner, simpler when you use the VAR. The type is obvious. So it's if you know the basic language, this is bleeding obvious, this is a Boolean. In addition, intuitively, I also have naming conventions to specify type. And this is a string because of the double quotes. Now, over here, I have commented, if we actually specified the type here, if a Boolean, does this make it any clearer than this? Well, maybe for a beginner where the type is a Boolean, but the Boolean over here, we can tell anyone who knows Java syntax, other programmers will be able to tell. If we specified a string, do we need to here? So this argument, okay, we don't need to do it. Is it any simpler? Well, some people argue that. I like this example. It's far more compelling than this one, but it's better than this one. So I like this one. You don't have to know this for an exam or a quiz, but I like this one. This is the clearest argument for it. This is the second one. Okay, I can live with this. This one, less compelling, but there are some pros of the VAR. There are some drawbacks, however. It can make the type under certain circumstances hard to determine, especially if you have lousy naming conventions over here. Lousy variable, you don't give a clue as to what type is. Get input, what types of input. Now this part, some people count it as a plus, I count as a minus. I try and write self-documenting code. I use that term in my first year classes, 217, 231, where essentially, in as much as possible, your code is clear what it's doing. You don't have to read documentation. In other words, you don't have to memorize language details. Well, in this case, looking at it, you yourselves at this point, is this going to be an integer or long? If you follow that rule I described, we look at the type over here, but this could be stored in either an integer or a long. Over here, is this a float or double? This has a fractional part, so you have to memorize, well, what does it pick as a default? The default over here, you have to memorize the detail, is that if you don't specify, by default, it'll be an integer, the smaller 32-bit value. You have to actually put an L here to make it long. And it's inconsistent over here. If you have a fractional value, then the default is a double, and it doesn't follow the rule where it's a smaller, it's a bigger value. And if you actually want to have the 32-bit floating point, then you put an F. And people said it's very obvious. I've seen people debate that, and I would tend to say, yeah, you got to memorize the details. So I'd say that, okay, it infers a type, you have to memorize details. So that's a minus. It's not as clear as it could be. Now, Java itself, it has rules for, is this a long or an integer? This has rules for this, but you have to consider you're writing for another programmer and you want to try and make it as clear as possible. And that's exactly what I'm getting at over here. And there are even worse examples, this one. So I have a different get count. Count is a counting number, so it's going to be a positive whole number of some sort. But then to determine the type, if we're trying to use a num, is it up to 64 bits or is it only 32 bits? And that can play, we have to determine that sometimes in our code. Then we have to look at the definition for get count and then check to see if it's int or long. So this is not at all self-documenting. This is even less clear in the example of this. Some people might argue that this is actually a pretty good thing with using VAR. I would argue against it. But in this case, not many people would argue that using VAR, we can tell the type. We cannot tell at all here without looking at the documentation.